how the neuron should really learn anything. So there's something called back propagation. The back propagation makes the neuron to learn new things, and here the learning implies minimizing the error that is getting from output of neuron and the real values. So what we do is we give the input to the neuron and produce the output, and then we try to match this output with the real output that we want, and we want to minimize the error between the output of neuron and our own real output. So that is a real output r, and the output produced by neuron, that is y. So we want to minimize the value r minus modulo of r minus y. So to minimize this, what we do is, and there are several different mechanisms to minimize this error, but the most famous one is gradient descent. A gradient descent is basically try to find the error, change in error with respect to the internal variables, and then manipulate the internal variables to minimize the error. So you can see there's a curve here, and this is the initial say initial weight or initial parameters. What we do is we try to find that whether it should go downward or upward. So through some mathematical operators, differential operators basically. So we try to minimize it by finding the direction through finding a direction where this weight should move. So you can see that if this is a parabolic like shape, and this is the initial weight. So if the ball rolls down to here, then the error will minimize. So this is exactly what we do in gradient descent. We try to find the weights that would minimize the local values. So machine learning try to optimize the initial weights of the neurons, so that the output of neurons produces less error, that is modulo of y minus e, or y minus r. So it tries to optimize that thing. This is actually called the back propagation. We take up the output and find the gradient descent and manipulate the internal weights to minimize the error. This is the overview of neuron, how actually the neuron works. But the problem with the neuron is, if you look at the mathematical model, what we do is we find the weighted sum. So this is a linear system, so it can only generalize the linear functions. But do we have all the functions in linear? Do we have? Nope. Like if we even take the trajectory of a ball rolling on say plane, it has a degree 2 equation. So linear function, we are not really concerned about the linear function. We want some really complex function to get generalized by the neurons, because we can generalize the linear function by ourselves. So we want the neurons to do some really difficult work for us. Like if we take the example of say image recognition. So image recognition have lots of things. The edge analysis, we to find the edges, and then we want to find the relation between edges. Say in the handwriting recognition, we want to find the edges that actually correspond to some character. Like U has a like parabolic like shape, and O has a circular like structure. So machine, and this can't be done with a linear neuron or any linear model or any linear system. So the next thing comes to machine learning is the architectures.
Thank you for watching our video on machine learning. For more videos and tutorial, like, share and subscribe. And don't forget to press the bell icon so you don't miss any cool videos.